Hi guys, welcome to Science in 5. In this video we're going to talk about the trigonometric ratios. Let's go. Suppose we take a line, join it to another line, such that we form an angle theta. Now let us construct a right-angled triangle, like that. Trigonometry is about right-angled triangles, the ratio of any of those two sides of a right-angled triangle. Let's start by focusing on the side that is opposite this reference angle theta. Let's call it the opposite side. The other perpendicular side to this right angled triangle will be termed the adjacent side. If we take a ratio of these two sides, it gives us a number. We shall call that number the tan of theta. So the tan of theta by definition is the opposite side divided by the adjacent side. So let's start by looking at an angle of 30 degrees. If we constructed a right angled triangle with the reference angle 30 degrees and we measured the ratio of the opposite over the adjacent side, we'll get an interesting number. In this particular triangle that we've got here, the ratio of the opposite side divided by adjacent side is 1,4 divided by 2,4. If we repeat this process and make another right angled triangle using the same reference angle of 30 degrees, such that we have another side opposite the same angle of 30 degrees, and we measure again the same ratio of the opposite side over the adjacent side, the ratio comes to 3,7 over 6,5. If we then go on to repeat this by constructing a number of right-angled triangles, all similar to the first right-angled triangle, the ratio of the opposite side over the adjacent side will approximate a number, 0,57. So the tan of 30 degrees approximates to 0,57. Interesting. That's what trigonometry is all about. The ratio of any two sides of a right angled triangle with a given reference angle approximating a certain number. Using the calculator, if you were to type in the tan of 30 degrees, the calculator is pre-programmed to give you that approximate ratio. And the calculator says, well, the tan of 30 is 0,577. The ancient mathematicians and students of science discovered this. So they tabulated these values where they got the angle and the approximate ratio of sides. They did it for a different number of angles, but we're just going to focus on, for now, 15, 30, 45, and 60. You can go on and on for different angles. So when the angle is 15, the ratio of the opposite over the adjacent is 0,268. When the angle is 30 degrees, the tan of 30 is 0,577. When the angle is 45, the ratio is 1. And when the angle is 60, it's 1,73. The tan of 45 is 1 because, well, it simply means the opposite over the adjacent gives us that ratio of 1, or the opposite side is equal to the adjacent side for a tan of 45 degrees. So that is how trigonometry works. So the trigonometric ratios are then based on this relationship between the ratio of any two sides of a right angled triangle. The adjacent side is the side that has the right angle and the reference angle. Opposite side, opposite the reference angle. The hypotenuse is always the largest side and is opposite the right angle. Sometimes we just like to use letters instead. Okay. So if we say the sine of theta, it's a ratio of the opposite side over the hypotenuse side. The tan of theta, or the tangent of theta, is the opposite over the adjacent side. The cosine of theta is the adjacent side divided by the hypotenuse. Using this acronym SOHCAHTOR, you can find it easier to remember these ratios. Start from the left going to the right. The big S, sine, is opposite of hypotenuse. The C means adjacent over hypotenuse, gives us the cosine ratio. And the T, the tangent, opposite over adjacent side. So guys, that is the basic introduction to these trigonometric ratios and how they work. So we've finished giving the brief introduction, but don't disappear yet, because now it's practice time. Let's practice how to use these trigonometric ratios to solve right-angled triangles. So in the first activity, we're given a triangle with sides AB, BC, and AC. We're asked to write down the following in terms of A, B, and C. The sine of A, the tan of A, the cos of B, and the sine of B. Let's start with 1.1. To write the sine of A, let's use our acronym SOHCAHTOR. Let's make angle A the reference angle. In other words, if we place an angle theta where angle A is, it will be easier now to name the sides of this right-angled triangle so that we can identify the ratio of sine. The opposite side is the one opposite the angle theta. The hypotenuse will be the one opposite the right angle. And then the adjacent side will be the one side that has got the right angle and the angle theta on it, like that. So the sine of theta is what? It's the opposite side divided by the hypotenuse side. In other words, side BC over side AB. The tan of theta will be what? Opposite side over the adjacent side. In this case, BC over AC. When it comes to the cosine of B, we're saying cos is always adjacent of hypotenuse, but we have to make angle B the reference angle. In other words, we can actually move that reference position. The reference angle in a right angle triangle can actually be changed. So let's move the angle theta to where B is. Now, if we do that, it means side AC is no longer opposite, is now the new opposite side rather. So AC is now opposite the reference angle. And BC is now the adjacent side. The hypotenuse side doesn't change. So we can actually swap the position of the opposite and adjacent side. We get cos B is now BC over AB, adjacent of hypotenuse. The sine of B, and notice the cos of B is equal to the sine of A. Later on, we'll talk about that. Sine B is opposite of hypotenuse, which is AC over AB. So, the opposite and adjacent sides are interchangeable. Only the hypotenuse remains the same because it's always opposite the right angle. If we shift the reference angle position, we can also shift the opposite side or the adjacent side position in relation to the right angled triangle. Okay, so that is how you can write down the ratios of sine, tan, and cos by using that. The next thing we want to talk about is how to use the calculator. For example, if you're asked to write down or to determine the value of the sine or the tan or the cos of an angle, how would you go about it? Well, let's start by looking at the sine of 75. On your calculator, if you type in sine of 75, it gives you 0.9659, which approximates to 0.97 to 2 decimal places. The cos of 45 will approximate to 0.707, which can round off to 0.71 to 2 decimal places. So all you do is just add cos and press 45 on your calculator and press equals, and the calculator will give you that number. Okay, and similarly the tan of 65 is 2.1445. Note that the ratio for sine and cos is always less than 1, whereas the tan relationship can always be greater than 1. Okay, so that is how you can use the calculator. Just press the sine 75, get that answer there. For the cos, do the same thing. Press the cos, the angle, get that answer there. Okay. Let's move on to activity 3. We're asked to solve for theta in the following equations, correct to 1 decimal place. Remember, solve means find the value of. So in maths and science, when you want to solve for something, we want the value of the variable. 3.1, we are asked, we're told sine theta equals 0.95, we want the value of theta. 3.2, the 5 tan theta equals 4.755, what will be the value of theta? Okay, let's go. For 3.1, we've got the sine of theta equals 0.95. What we want to do is to get rid of the sine function on the left hand side and remain with theta. How do we do that? Well, if we use the arc sine, inverse of sine function, we can actually multiply that with the sine function and get 1. So on our calculator, this will be the same as pressing shift and sine. Okay, so if we say on the left hand side, let's find the arc of sine, inverse of sine, and multiply it to sine. What will end up is that we're going to multiply the inverse of sine with the sine function, and then we're going to get rid of that and remain with theta on the left hand side. Whatever we do on the left hand side, we also need to do on the right hand side. Okay, so the next step now is the sine functions on the left hand side. They're going to cancel out. Okay, and this will leave us with what? This will now leave us with theta is now equal to the arc sine of 0.95. I know it looks like we're saying sine to the power of -1, but that's not it. It's not sine to the power of -1. It's actually the inverse function of sine. So theta is now equal to the inverse function of sine times 0.95. So on your calculator, press second function sine 0.95 and you get 71.805. Again, second function sine 0.95 and you get that angle. Okay, now moving on to 3.2. 3.2 is quite interesting because we've got coefficient in front of the tan function. Okay, so now we've got a coefficient that is multiplying the function. In other words, we've got a 5 times the tan of theta equals that number. The first thing we want to do in this case is to get rid of that coefficient. We need to remove that 5. And how are we going to do that? Well, we can divide both sides by 5. If we divide both sides by 5, we get rid of the 5 and we'll remain with the tan function like that. So 5 tan theta over 5 equals 9.455 divided by 5. Leaves me with tan theta equals 1,891. The same way we did to get rid of the sine function, we use the inverse of sine. Let's use the inverse of tan to get rid of the tan function on the left-hand side. So we now know that if we use the inverse of tan on both sides of this equation, this allows us to get rid of the tan function on the left-hand side. This now leaves me with theta is equal to the inverse of tan of 1,891. Again, on the calculator, press second function or shift and then press tan. On some calculators it's the shift button, on some calculators the second function button. So you're going to press shift tan 1,891. Press shift tan 1,891 and the calculator will give you a result of 62,129, which becomes 62,1 degrees. So we can actually solve trigonometric equations by first making sure that we've got a single ratio of the function without a coefficient, and then we can use the inverse function from then on. Okay, a point to note, guys, is that remember, trigonometric ratios are based on 3 variables. It's a 3-variable formula. There are 3 variables in that formula, and you're going to be asked to work out one of those variables. So which means you always need to have at least 2 of the other variables. To calculate a missing angle, we need at least 2 sides. Okay? To calculate a missing angle, we need 2 sides. To calculate a missing side, we're going to need at least 1 side and 1 other angle besides the right angle, which makes sense. These formulas or these relationships always got 3 variables in them. So we need at least 2 of them to work out the third one, which is the unknown variable. Okay? Alright, so trig ratios, very simple to work with, as long as you remember SOHCAHTOA. Okay? Use SOHCAHTOA initially as you go on, but with time you discover that you probably won't even need to use the SOHCAHTOA. You begin to remember the ratios. Continuing with our practice time. So what I'm going to do in this segment is, if you get an opportunity, you can pause the video. Pause the video and work out the question by yourself, and then compare answers. Let's see what we get. So in this following example, we need to determine the side marked with the letter correct to 2 decimal places. Okay, guys, you can pause the video at this stage and work it out for yourself, and then see if answers are similar. Let's stick to 1.1. If you observe, the side that is marked X is the side opposite the reference angle of 30 degrees given. Okay, so that's the opposite side. Therefore, the other perpendicular side must be the adjacent side. Okay, so we've got the 2 sides that we're going to use to solve this problem. The opposite side and the adjacent side. What ratio works with the opposite side and the adjacent side? Well, it's the tan ratio. Remember, we said the tan is equal to the opposite side over the adjacent side. So we can actually say the tan of 30 is equal to opposite side over the 6,5. Okay, you can use SOHCAHTOA. Again, remember, the idea of SOHCAHTOA is to try and help you remember these ratios quickly. After a while, you probably won't need SOHCAHTOA. You'll be able to just almost naturally write down the ratios of these right angle triangles. So let's use the tan function, opposite side over the adjacent side, to solve this problem, because the information we have links us to the tan. So the tan of theta is the opposite over the adjacent. X over 6,5 equals the tan of 30. At this stage now, what you want to do is to make sure you make a ratio of the two sides. You know that any variable or term is always being divided by 1. So the tan 30 is also being divided by 1. So now I've got tan 30 divided by 1 is equal to x divided by 6,5. What you're going to do in the next step is to cross multiply the numerator times the denominator. The numerator on the left times the denominator on the right. Numerator on the right times the denominator on the left. This will give us 6,5 tan of 30 is now equal to x. On the calculator, type in 6,5 tan of 30, or 6,5 times the tan of 30. You probably don't even have to add in the times function. Just write 6,5 tan 30, and your scientific calculator will understand what you mean and will tell you x is equal to 3,75. So it's always important to use the information given. Figure out from the information given which two sides are given and which ratio can I use. 1.2. You're given the opposite side, and the side that we want to work out is the hypotenuse. Opposite of hypotenuse is with which ratio is this? Well, the opposite over the hypotenuse is the sine function. Okay, so in this case we can use the sine to actually solve the problem, because we are given the opposite side, the side opposite 50 degrees, and we're given the hypotenuse side is the other side that we actually want to determine. Okay, so let's use the sine function because it works with the opposite side divided by the hypotenuse side. So sine of 50 degrees, okay, the sine of 50 degrees is equal to, the sine of 50 degrees is going to be equal to 5 divided by y. That will be your first opening statement because we are using the sine function. Okay, so the sine of 50 degrees is going to be opposite over the hypotenuse, which is going to be 5 divided by y. Again, we want to make those two sides, the left hand side and the right hand side, ratios. In other words, the sine 50 divided by 1 is going to be equal to 5 over y, so that we can do that trick of cross multiplying. Okay, we can do the trick of cross multiplying. With practice and after some time, you'll discover that you won't even need to write the sine 50 over 1. You should be able to see it like that. But since we're introducing it, let's just write it down like that. Cross multiplying, we get y times sine of 50 equals 5. Because we've cross multiplied, so you get y times the sine of 50 is now equal to 5. So what we need to do here is now to divide both sides by the sine of 50, because we want to isolate the variable y on the left hand side. So let's divide both sides by the sine of 50 degrees. So y sine 50 over sine 50 is now equal to 5 over the sine of 50 degrees. Okay. This gives us y equals 6,527, which we can round off to 6,53. Well, in question 1.3, again, we need to use the given information. Because we're working out a side, it means we've got an angle in the side. So let's figure out what are the sides given that we can use. If we look at the 10,5, we can see that it's opposite the right angle. That's the hypotenuse side. The side marked Z is the adjacent side. It is the side that has got the angle of 75 and the right angle. So that is the adjacent side. Adjacent over hypotenuse gives us the cosine ratio. So to solve this problem, let's use the cos of 75. Okay, because the cosine relationship is based on the ratio of the adjacent side over the hypotenuse side. So cos of 75 is equal to x divided by 10,5. Again, we can now say the cos of 75 divided by 1 is equal to the z over 10,5. Okay, from there we cross multiply again. We get 10,5 times cos 75 equals to x, and x is equal to 2,72. Alright, so it's always important that you learn how to work with the given information. The given information will allow you to isolate a particular ratio or a particular function. It could be the cos, it could be the sine or the tan. So the given information will always allow you to do that. Once you do that, you can easily solve the problem. Okay. All right. Moving on. The next problem. Triangle ABC. And you're asked to calculate the size of angle A, angle C, length of BC. You can pause the video and try this one by yourself and see how our answers compare. Okay. To get the size of angle A, we need to make A the reference angle. So it doesn't matter that this triangle looks like it's inverted. We can still figure out which one is the opposite side, the adjacent side, and the hypotenuse side. So once we make that angle A the reference angle, we can now see the other sides of the right angle triangle. The hypotenuse is obviously opposite the right angle, and the side opposite the reference angle is opposite side. That makes side AB adjacent side. So since we want to work out the size of the angle A, we've got adjacent and hypotenuse. Adjacent and hypotenuse, or adjacent over hypotenuse, gives us which ratio? Well, if we look at SOHCAHTOA, adjacent over hypotenuse is actually the cosine relationship. So to get the angle A, we can actually use the cos of theta. Why? Because we are given the adjacent side and the hypotenuse side. So the cos of theta is adjacent over hypotenuse, which becomes 5 over 7,5. And we now know how to get rid of the cos function on the left hand side. We use the inverse of cos, but we have to do it to the left hand side and also to the right hand side. So now this leaves us with theta is now equal to inverse of cos of 5,75, which is 48,18, which you can round off to 48,2 degrees to 1 decimal place. Once you get a piece of information, guys, quickly add it to the diagram so that you can easily see how this puzzle is coming together. Remember, it's almost like you're adding pieces of a jigsaw puzzle. Once you find one piece, add it to the diagram. It makes it look easier as you proceed. To work out the size of angle C, let's use the properties of a triangle. The fact that we are focusing on trig, guys, doesn't mean that we have to neglect the other properties of triangles. For example, the interior angles of a triangle. The sum of the interior angles of a triangle, they add up to 180 degrees. So angle A plus B plus C is equal to 180 degrees. So we can find the magnitude of angle C by simply using that and solving for C, because we've already got the other two angles. 48,2 plus 90 plus C equals 180 degrees. Take the 48,2 and the 90. Oh, pen sliding here. Take the 90 across. Okay. You end up with angle C is now equal to 180 minus 90 minus 48,2, which is the same as 90 minus 48,2, which is 41,8 degrees. Alternatively, you can just say C equals 90 minus 48,2. Why? Because we know that B is already 90. A plus C must also equal to 90. Therefore, C must be 90 minus 48,2. So once you get the other angle of a right angle triangle, the other acute angle is 90 minus that angle. So C is now 41,8 degrees. So this puzzle is coming together slowly. Okay. Having found out that C equals 41,8, we now need to figure out the length of BC. It looks like on this triangle we've got quite a lot of information. We've got some options now to calculate the length of BC. Okay. Again, it's a right angle triangle. You can use trig, but there's also another theorem that you can use, because you've already found two sides of the right angle triangle. Let's start with the trig. Okay. BC is the opposite side in this case. We can use the opposite over the adjacent. Okay. In other words, we can use the tan of theta to find out what BC is. We'll use the tan of 48,2. And the adjacent side is 5. At this stage, we now know that we can make those two sides ratios, cross multiply. 5 tan 48,2 equals BC. BC equals 5,59. You can round that off to 5,6 to one decimal place. Alternatively, we can use another ratio. Because BC is the opposite side, we can use the hypotenuse as well. BC and AC. So the sine of 48,2 equals BC over 7,5. Do the ratio thing again. Guys, at this stage you should be able to do that. Cross multiply. You now get BC is now equal to 7,5 times the sine of 48,2. So side BC equals to 7,5 times the sine of 48,2, which comes again to 5,59. You can round that off to 5,6 centimeters to one decimal place. Alternatively, we can use the theorem of Pythagoras to solve this problem. Remember the theorem of Pythagoras? AC squared plus AB squared plus BC squared. AC squared rather equals AB squared plus BC squared. 7,5 squared equals 5 squared plus BC squared. You can now solve for BC squared. Okay, so BC is equal to 7,5 squared minus 5 squared. BC is 5,59. You can round that off to 5,6. Okay. Guys, remember the theorem of Pythagoras. We've talked about it in one of our videos. You can check out that video and it will discuss the theorem of Pythagoras in detail. So that is how you can solve a problem like this. Remember, don't focus only on the trig. Use also the other ideas of right angle triangles that you know. For example, the theorem of Pythagoras and the idea of the interior angles.
In the next example,
of a
two right angle triangles ABC and ACD are joined together as shown. Side AC is the common side to these two right angle triangles. So normally when you get a right angle triangle, the common side, usually the common side is a clue to solving the puzzle. Okay, so we must use the common side given. Okay, what is the question? Determine the size of angle ABC. Now, to determine the side of angle ABC, we need to have what? 2 pieces of information. Okay. Remember, the trigonometric ratios are 3-variable formula. We have got 3 variables in them. So to solve for any one of those variables, we need at least 2 pieces of information. For an angle, we always need 2 sides. If you look at triangle ABC, we've only got one side, 5 centimeters. So somehow we need to get another side so that we can find that angle. We need to think of the common side AC. Okay, so look at triangle ACD. If you look at triangle ACD, you look at AC is the hypotenuse and CD looks like it's the opposite side. So we can use the sine relationship in triangle ACD to calculate side AC. So let's determine side AC by using the sine of theta. At this stage, I'm sure you can do that. The sine of theta is the opposite side over the hypotenuse, CD over AC. And then from then on, you should be able to quickly calculate what AC is going to be. Sine 40 is 4 equals 4 over AC. Therefore, by cross multiplying and then dividing, AC equals 4 over sine 40, which is 6.22 centimeters. Now that we've got side AC, we can now determine the angle ABC because we've got 2 pieces of information. Okay, look at triangle ABC. Side AC is opposite the angle. Side BC is the adjacent side. So let's use the tan relationship. So the tan of theta is opposite of adjacent, 6.22 over 5. Now we said here we use tan inverse of 6.22 over 5, or the arctan. So the inverse of tan, we've called it the arctan, or we can just say tan inverse, and we get an angle of 51.2 degrees. So the important thing here was to note that we've got a common side in that example. Okay, guys. Our last example, we now have got sides labeled X in a right angle triangle ABC. Angle B is 90 degrees. Angle C equals X. Side AB equals 1 over 3X. And AC equals half X. Okay. Determine the length of the sides of the triangle as well as the other interior angles to 2 decimal places. So we are basically solving this right angle triangle, guys. Okay. How would we go about doing this? Well, look at the information given. We're given 3 pieces of information. Okay. We are given side AB and side AC. Now, if we were to label the sides of this triangle, side AB will be the opposite side. Side AC, the hypotenuse opposite the right angle. So opposite of hypotenuse leads us to the sine of theta. It's the sine of X in this case. Now the opposite side is given as 1 over 3X, and the hypotenuse is given as a half of X. So let's use that. Sine X equals 1 over 3X divided by a half of X. Dividing, I can see that I surely can cancel out the X's because I'm dividing X and X. So rather write it as X over 3 divided by X over 2. Because a third of X is the same as X over 3, half X is the same as X over 2. What do you do when you've got division of fractions? Change division sign to multiplication and invert the second fraction. So it's now X over 3 multiplied by 2 over X. Okay, guys, remember how to divide fractions. Invert the second fraction. Pencil there, but you invert the second fraction. Okay, and then what do you do? So the denominator becomes the numerator becomes the denominator, like that. And then change division sign to multiplication. Now, we can now easily multiply. We can even say 2 times x over 3 times x. But what we can also do is we can actually divide the x's now. The x on the top and the x at the bottom. So now we remain with sine x equals 1 over 3 times 2 over 1, which becomes 2 over 3. So now we've reduced the sine of x to a single ratio, 2 over 3. Again, now we need to work out sine inverse, or the arcsine of x. Okay, so x is now equal to the arcsine function of 2 over 3, or the arcsine relation of 2 over 3, which is the same as the inverse of sine, but we just say arcsine. Okay, x equals arcsine 2 over 3, which gives us 41,81 degrees. So the value of x is actually 41,81. Okay, but in the case of an angle, it becomes 41,81 degrees. Now, once we know what x is, part of this puzzle is already solved now, because for side AB and side AC, we replace x there and we can solve. And once we know what angle C is, we can easily work out what angle A is by using the properties of a right angled triangle. Once you know the other acute angle, the third angle of the triangle will be 90 minus the given angle. So 90 minus 41,81 will give you 48,19 degrees. So angle A is now 48,19 degrees. Now, to work out the sides, it's just an issue of now replacing the x 1 over 3 times 41,81, 1 over 2 times 41,81. So side AB is 1 over 3 of x, but x is 41,81. So 1 over 3 times 41,81. AB is actually 13,94 units. Okay, and AC is going to be equal to half of 41,81, 20,91 units. And again, once you solve part of the puzzle, add the pieces so that you see what is left. We can clearly see that now we're left with only side BC of this puzzle. And guys, now we can now even use the theorem of Pythagoras for side BC. You can use the trig ratios again for side to work out side BC. In this example, we've used the theorem of Pythagoras. Again, that we have a video on the theorem of Pythagoras. If you're stuck there, you should get BC equals 15,59 units. Okay. Alternatively, you can use the trigonometric ratios. For example, you could use the tan relationship. Okay, if you use the angle 48,19 as a reference angle, BC becomes your opposite, AB becomes your adjacent. So tan of 48,19 is equal to BC there over AB, like that, which is BC over 13,94. Doing the cross multiplying technique, we get BC equals 13,94 times tan 48,19. You get BC equals 15,59. Okay, so remember, with trigonometric ratios and solving problems of right angle triangles, always use other theorems of triangles as well. So let's check out our answers if they make sense, right? We've said C is 41,81. So the sine of 41,81 should be equal to 13,94 over 20,91. We're just checking if the answers make sense. So on the left side, sine of 41,81 is 0,67, and that ratio is also equal to 0,67. So our answers seem to make sense. Okay. So that's it, guys. We've introduced the trigonometric ratios, the sine relationship, the sine function rather, the cosine function, and the tangent function. We've also looked at the inverse of those functions, of those ratios. In the case where we want to work out the unknown angle, we have used arc tan, arc sine, and arc cos, which simply means the inverse of that function. So on your calculator, you'd press shift or second function, then you press that sine or cosine or tangent button, and you get the calculator writing, for example, sine to the power of -1. But you know that it doesn't mean sine to the power of -1, it simply means the inverse of sine or the arc sine. So there you go, guys. Thanks for watching. Add some comments, share this video. So in the next video, we'll continue talking about trigonometric ratios on the Cartesian plane now. We're going to introduce the idea of a unit circle, and we're going to see how the relationships pan out when we now use the Cartesian plane, the y-axis and the x-axis. See you soon, guys.